The topic of discussion today is troubleshooting using vCenter Operations Manager. My name is Praveen. I'm one of the product managers for vCenter Ops, and with me is Kit.
Hi, I'm Kit. I'm the tech lead for the VC Ops suite, and today I'll be doing a live demo.
If all goes well.
If all goes well, yeah.
So let's take a quick look at the agenda. So we're going to start out with a quick introduction to the vCenter Operations suite, talk a little bit about the product concepts, and then we're going to jump into a demo that Kit will do where we'll go more into sort of the day-in-the-life scenarios, things that you worry about on a day-to-day basis, and sort of show the product through those scenarios. And then we'll come back and recap what we saw and then open it up for questions. During the demo, we also want to make it interactive, so feel free to ask questions at that time. So let's just jump into that. So we heard Paul and Steve talk about heterogeneous cloud management, and we really want you guys to be successful in that. To that end, we believe that there are three things you need to do there to make a heterogeneous cloud a reality. So the first one is obviously the provisioning aspects of it, whether it is provisioning infrastructure, applications, or anything else, and then couple that with good operations management that meets the cloud's use cases, right? To get the level of service levels you need. And finally, the set of IT policies, the governance that you want to put on top of it, and the controls. That's sort of the VMware's management stack. So if you sort of double-click into the operations management aspect of it, specifically, the vCenter Operations Suite is focused on like three domains of areas of functionality. So one is about being sort of best in class for our vSphere stack and all the software-defined constructs. The second one is about being comprehensive, because we fundamentally recognize that you have existing IT investments in place, and the ability to give you that single pane of glass kind of feel across not only your virtual stack, but your applications, your public cloud, and provide that visibility. And then finally, to get that level of automation, which is all of what cloud is all about. It's the agility that you demand. Now, if you take a sort of a functional view of the world, really, if you look at this graph, it gives you a perspective of all the functional domains. So on one end, we have what we call as the performance capacity config, sort of the main three pillars of the ops management suite. And then we have the cost metering, because it's also about being able to inform to upper management what's going on in the environment from a cost perspective, and then finally the regulatory and the industry best practice and the compliance controls. Coupled on top of that is a set of common services. We have application visibility, reporting, orchestration. These are sort of the cross-cutting use cases, if you want to call it, across these layers on top of a single unified interface. So now what we're going to do is just zoom into the performance, capacity, and config domain, which is sort of the main three pillars of the suite. And then I'm going to show you some use cases on how we feel that these three domains should come together for proper operations management of the cloud. So with that, I'll introduce you to the vCenter Operations Manager dashboard. Now this dashboard is where we see all of the domains of functionality coming in. So we talked about performance, capacity, config, and so the dashboard is centered around that. And more importantly, some of the customer feedback we heard in the past is that folks are overwhelmed with the amount of information they consume today when they do operations management. And they're trying to make sense of all the key metrics that we keep talking about in the different VMworlds or the white papers, the best practices. And a lot of times, they ask the question like, what does all this really mean, right? I mean, how do I manage at scale? I can no longer go and look at my favorite cluster or pick up that rogue Java app the guy always messes around with and then start with that. I really need something that informs me at a high level what's going on in my environment, where are the problems, and what can I do next. So we had that high-level concept in mind and really wanted to take the guesswork out of all of this mumbo-jumbo and then really sort of give you information that helps you, in the end, solve the problems you're going after. So to that end, what we've done is that we've taken all that knowledge from the VMware best practices and from our engineers, and we've codified all of that into the product itself. And what we do is we provide what we call as these badges that inform you what each problem domain is all about. At the end of the day, you don't worry about the metrics or the events. you really are interested in what is the problem, right? What is the problem that I need to be worried about? So you see these pretty pictures and sort of the icons. These are essentially the badges, and each badge has a score. And each badge informs a specific domain of problems. And we sort of organized it on how you guys think about it, right? So on a day-to-day basis, you come in, you think about, okay, what kind of firefighting do I need to do today? What are my important issues that I need to worry about now? And then you think about, okay, can I be a little bit more proactive? What are some of the building performance issues I need to be worried about? And then finally, when you have some time at the end of the month or a quarter, you can sort of relax and see, okay, can I do something more? Can I do more with less? So that's sort of our fundamental thinking behind the dashboard. We've organized it based on immediate problems, future problems, and then opportunities to optimize. And you'll see that the suite, or sort of the modules you saw, the performance, capacity, config, cost, and compliance, they all come together in this dashboard and sort of front and center to inform you of the problems. And then you can go drill down into the special tool for that next level of drill down. So let's take a look at all these three badges I just talked about. So I talked about health, and that informs immediate issues. So what does it really tell you? So the health is a combination of three sub-badges. So one is called workload, the second one is called anomalies, and the third one is faults. What workloads really tells you is that how hard you're really pushing this resource. Is sort of the demand of that resource, is it exceeding the allocated capacity, right? And we have a score for that. Obviously, a low number is good here, but you may see workload scores more than 100. It's not a limit. It can be even 300, 400, 1,000 even. It just informs you how much of sort of multiples it actually the demand is, right? And then we have anomalies, and this is where sort of the power of the analytics come into the product. And again, it's all about managing its scale and sifting through the noise. Anomalies sort of informs you how is this workload behaving as per normal business activity. Is it behaving as it should be, or is there a sudden clip? So you can sort of use that perspective to figure what's going on. Then finally, we have faults, and faults is just sort of this up and down status, right? Somebody pulled a NIC, or you have a path failure, sort of, or VC goes down. Get all those faults in, and then the combination of all of these three things informs the health score. Then we have risk, and talked about it informs future issues, and this risk badge is a combination of three sub-badges again. One is what we call as time remaining. Now time remaining informs you the specific metrics such as CPU, disk, memory, network I/O. How much time do you have left? There may be specific metrics that or specific domains of functionality that are taking up more of your resources, so you need to be informed with that and sort of plan and stay ahead. So at a granular level, we show you how many days you have time remaining for each of the metric groups. And we also express that in terms of the number of virtual machines you can deploy, because that's how you guys think, right? In terms of, okay, what does all this mean? So even if disk I/O has got 11 days left, what does it mean? Can I meet the business demands? They ask me for at least 100 VMs. Can I provision it onto this cluster or host, right? That's what capacity remaining shows you. How many VMs can I fit given the object that I've just selected? And then finally, we have stress, which informs you over the business week, how have you been performing, what are some periods of real stress, how hot am I running my environment when batch jobs happen, or over the week, what are my normal periods of business activity. And this is sort of a nice contrasting indicator compared to workload. So on one end, you have sort of the reactive issues, right, on workload, and then you have sort of the building issues and stress. And the way I like to troubleshoot typically using these badges is always take them in context, right? Each of these individual badges inform one specific domain of a problem. And you should always sort of look at that domain and compare this with this domain and sort of come up with a collective sense of what's going on. So on one end, you could have, workload high, and then stress could be less, but then, what is that sort of cause and effect, culmination of it? Finally, we have efficiency, and efficiency is all about doing more with less. You have a lot of waste in your environment. Typically, we even count idle VMs as waste. They're hogging up resources, right? So we provide you a breakdown in terms of reclaimable waste how much waste is there in your environment in terms of idle, powered off, or oversized VMs. And what's really good about this is that you no longer have to go have this conversation with the developer and saying, look, you don't really need that 16 gig VM with 8 vCPUs. Instead, you just provision the VM, come back to him and say, look, I have data to prove that you're not really using what you said you really wanted, right? So that's the waste score. And then finally, density it allows you to pack more on the same box without affecting performance. So this actually shows you how much more you can pack without negatively impacting performance of your critical workloads. And then you have these ratios that inform you how you can achieve that. So we talked about a lot of this coming together. And then what I would like to do is hand it over to Kit, who's going to go over some few day-in-the-life scenarios and make sense of all the stuff that we just talked about today. Thanks, Kit.
Okay, so this is going to be a live demo. For people in the back, we've tried to make the resolution as small as we can, like this resolution, so it'll appear bigger on the screen. But if you can't see it, there are some seats in the front if you want to move up. So what we're going to do is walk through a few different scenarios here. You can see them here. I'll come back to them as we go through each one. The first one is around slow performance of an important workload. So let's switch over here. Okay, this is the UI. And as Praveen mentioned, this is the dashboard. We have our 3 main badges here, health, risk, and efficiency. And they give you a breakdown as to how the object is doing right now, as well as how is it doing in the future. There are future impending issues, as well as any opportunities for optimization. So let's walk through a few different examples here. Now, one of the things that I like about VCOps is that it will tell you when there's a problem. So we can see here a few different alerts, and these, whoops, whoa. I'm not a Mac user, somehow I've already angered it. Okay, so, these corners, they're not intuitive to me. Never mind. So we get a list of the problematic VMs here. We have alerts for them. So vCOps is saying, hey, there's something going on here. So we can double click here and get it brought up. Okay, so everything's working thus far. That's great. Okay, so we get a couple of things. Why, the impact, who's affected, and then what we believe to be the root cause. So the root cause of the alert is that the object's demand is 98% of its available capacity. Right? So we trend the capacity, we trend the demand, and we say, wow, it's really close to running out of headroom here. And it also says disk I/O is the most constrained resource. So again, I apologize if this is too small for those of you at the back. There are some seats up in front if you want to come get a closer view. I'll try to read out everything that's important, though. Okay, so we say, okay, 98% disk I/O. We see the 98% here. Workload, this is the badge that Praveen talked about. This is what we're looking at in terms of performance, real-time performance. And so the system says disk is the problem. So we can verify that visually. We can say, okay, CPU, it's green, not too bad. Memory here is looking okay, pretty low. Everything's green. Whoa, okay. So disk I/O it is. Then it looks like network is also really low. So disk I/O is bright red, right? So that's clearly an issue. So what we can do is we can always drill into the VM. Now, one thing I do want to say is sort of interesting is that we capture the state of the VM in the alert at the time that the problem happens. So this is actually in the past. So we can click on the VM to see what's happening right this moment. All right, looks like we still have a problem here. You can see again the 96%. Very quickly here, we see CPU fine, memory fine, up, disk I/O still our problem. And of course, this visualization looks very identical to the alert, and that's actually the point, because the point is the alert is about this performance issue. So this performance issue is still ongoing. So okay, we need to figure out why it's happening, what's going on here. So let's move to a different view. This is a view that I like. Internally we call it the Skittles View, because it sort of looks like Skittles. It had a black background originally, it looked more Skittles-ish. But the main point here is that what we do is we actually represent each object in your inventory as an icon. The icon's in the shape of the badge, and this particular badge we have selected is workload. So we're seeing the workload for all objects. Now, one of the interesting things is that you can see, maybe hard to see, but down here is my VM. This is the one I have selected. It's marketing backup 1. It's having a problem. And you can also see that all the other VMs have been sort of grayed out, as have almost all the other hosts and data stores. There are one data store and one host that are still highlighted, as well as a data center and so forth. And so what's happening here is that vCops is actually showing you which objects are related to this problematic object. So obviously, if the host that the VM's running on has a problem, that will affect the VM. If the data store that the VM's running on has a problem, that will affect the VM, so on and so forth. And so you can actually get an idea of how widespread this problem is. So let's take a look. We can select the data store here. Because it's a disk I/O problem, I would just imagine it's likely a data store issue, right? Maybe this thing's the bottleneck. Well, we see one. So again, this is sort of hard to see, and I apologize. These icons are pretty tiny since we have 700 plus VMs here. It's easier to see when you're 2 feet away from the monitor rather than 100 feet away. But one of them is green and one of them is red. So, well, I'm not too sure. Let's dig down and get a little bit more details. Okay, so now you'll see a similar detail screen here that we saw for the VM, but this time we're looking at a data store. Now let's take a look. 100%. Okay, well, that's not good. 70% disk space utilization. Well, that's a little bit worrisome for my policies, but that's not the cause of this issue. And then disk I/O. Okay, so disk I/O is up at 100%. Okay, so that's probably a problem, right? It looks like the disk I/O for this data store is getting maxed out. Now, whenever you see something like this, you want to ask yourself, okay, who's causing it, right? Who's using all this? Is it one giant VM, or is it a bunch of tiny VMs, or what have you? So we have another view I want to look at, but first what I want to do is expand this. You can see we're VPNing into an RDP and SSHing somewhere else to finally get this thing, so it's a little bit slow. One thing I didn't point out before that I wanted to just real quick is that you can actually see, you get a very similar view to what we have in the vSphere client here. So you get the same sort of inventory tree. Right now we have this data store here selected. That's what we're looking at. So anyway, let's turn it over to what I like to call the heat map view. This is what we also call the analysis view. And I'm going to select the data center just for demo purposes because it gives us a bit better visualization of this one. And I will select storage because we want to ask questions about the storage within this data center. And I want to get it broken down by VM. Now that gives us a few options here. We'll select the first one. Let me close out. To make the best use of our screen real estate, let me just close all this stuff out here. Pop open this main visualization. Okay. So we have our nice visualization here. Now what we call these are heat maps, or technically they're tree maps. They're hierarchical views. And what you see is the boxes on, those corners again. Okay, the boxes on top are the data stores. So we have 3 data stores in this data center. We have data store 1, we have a data store called VMs, and we have data store 1, parentheses 2. And then we actually have a few more down here. We have lab storage and so forth, and there's a few others. Now, within those, we actually have the VMs. So we have one called Virtual ESX 5.0, parentheses 1, another marketing thing here. So you can see the different boxes here. Now you notice a couple of things. These boxes are both sized and they're colored. So they're different sizes and different colors. Well, what does that mean? Well, the sizes are actually the amount of I/O that each VM is pushing to that data store. So you can see that, relatively speaking, for data store 1, this virtual ESX box is pushing a lot of I/O compared to everything else running on it. And we also color them. And so the color here, and again, this is completely configurable. We've just selected one of the visualizations. The color here is looking at latency. So what's the latency to this data store? Green, 0. Red, in this case, is up to 300 milliseconds, it looks like, which is insane. Okay, so let's take a look at our interesting one here. That's data store 1, 2. So here's marketing backup 1. So we see that it's pretty big in size, which indicates it's pushing a lot of I/O. We have regular marketing backup no 1, and it's much smaller. And you also notice that marketing backup 1 is very red, so it's suffering from a severe amount of latency, 300 millisecond latency to this data store. Now, we have 2 VMs on this data store we see here, and they're both pretty red. And so what I would ascertain from this, just by looking at it, we can see details here. You see the specific latency and so forth. But what it looks like is that this data store is simply under-provisioned. When you think about ESX and Virtual Center, one of the things we do there really well is for each data store, we show you the size, right? And we give you a good indication of who's using what space within a data store. But data stores also have I/O limitations, right? There's so much IOPS they can drive. There's so much throughput in terms of kilobytes per second that they can drive. And those are really important indicators as well. And unfortunately, Virtual Center doesn't always show us that. And so what happens here, in this particular case, is that more than likely, there's just not enough spindles backing this LUN. And thus, it can't handle these backup processes that we're doing here. So the fix is to call up the storage admin and say, hey, here's my specific data. I've seen this latency. I've got 2 VMs, one of which is driving this utilization here, 7.2 megabytes per second. I can get its latency, I can get its IOPS, I can get all the data and give that to storage admin and say, okay, fix it for me, right? Here's the data, this is what I need. This many IOPS and throughput and so forth I need, fix it for me. So this is one example, right, where we saw the vCops alerted us to a problem, we were able to dig down, find out who the users were, understand that it actually wasn't any particular user that was a problem, but was actually just too many of these users, these VMs on this one data store. All right, so that's the first one. Any questions on that one thus far? Okay, so on to the second scenario. So the second scenario is one I'm sure you all are very familiar with. A user calls up complaining, my VM is slow. So let's switch back and take a look at that. Okay, so let's sort of revert here back to our dashboard. Okay, so someone calls up and they say, wow, my VM's really slow. And we say, what's the name of it? And they say, oh, it's 2011 Q4 BI. Okay, here we go. So you can see that vCops is actually suggesting VMs to me as I typed. And that's great. Okay, so what's going on? Health is sort of okay, but they said they're having a problem, so let's take a look at it here. Health actually rolls up many different things. Risk, we do have a lot of risk. Not too worried about efficiency right now. Okay, so we have a workload problem again. So here's an interesting thing about workload. So this workload is at 9,000%. Seems a little excessive. I actually don't know so I didn't create this demo environment. I don't know what they ran to get 9,000%, but something's killing this VM. Now, here's an interesting thing. You'll notice that health was actually pretty high, right? Yet you're saying, well, health is high, but we have a workload problem. This thing's having a performance problem. And as it turns out, the actual thing that's happening here, and I can see this just from looking at the screen, is that we have a very high degree of what we call stress. So stress is long-term workload. Remember from Praveen's definition, workload is about the here and now. It's about the instantaneous value of what this VM is doing. Stress looks at workload long-term. It says over the past 4 weeks, 6 weeks, what have you, how hard has this VM been working and when? So 7 days a week, 24 hours a day, 168 hours in a week, what's it been doing in those different hours? So this visualization here plots 168 data points and colors them by how hard that VM's working. And as you can see, for a significant chunk of the week, this VM's working ridiculously hard. It's red for a continuous 4 days or 3 days. Right? And it's like that every week at the same period during the week. Now, vCops has a bunch of analytics in it, sort of two sides, capacity analytics as well as performance analytics. So the performance there we go again. Performance analytics, this thing's more ornery today than it was yesterday. But the performance analytics now, what they're asking is, do you have a real-time performance problem? And what they're saying is that, hey, look, this workload's high, but it's been high. So you talked about, or Praveen talked about anomalies. Is it normal or not? And what the system is saying is that this is totally normal. This is not abnormal. The fact that you have this really high workload is just the way it's been for the past few weeks. So I'm not sure why these guys took so long to call, but what I can very quickly find out just from looking at these 3 different plots here is that this is not a new problem. They've been having it for quite a while. And that we can see exactly when it's occurring. So this is why health was so high. Health was high because health is saying, look, if this was a problem, you probably would have heard about it a long time ago, right? But since no one's complained, then the system will learn that behavior and say, well, you know what, things are probably okay then. At the same time, the capacity analytics are running and saying, well, hold on a second. I actually do see a problem. And so that's why you see the risk being so high. Risk is like, whoa, you got so much stress here, this is insane. Okay, so now we understand that, right? This is not something that's a one-off or something that's transient that just occurred randomly. This thing's been happening. So because it's been happening, we want to take a longer-term view of it. In the previous issue, we saw how we went into the operations tab to view it because it was something that was an ongoing performance problem. This one is a longer-term chronic issue, so we want to look at planning. Planning is where we go for this one. Now, we get a similar view in planning to what we got in the operations tab. And that is that we can see all the different objects in our environment, and they're colored by how they're doing. So we can see as I said, all the different objects and all the different relationships as well. So now let me get to the one we want. So we saw there's a problem with stress, right? So let me go over here and select stress. So the badge will change, and so now we show the stress score for every object. Before we were showing risk, now we see stress. So how stressed are these different objects? Well, we see that, we see my VM here, and then we see the host is also stressed. Data center is even a little bit stressed. But I'm particularly interested in the host. So let me look at this host here. Let me select the host. Now, when we select the host, what we see is, indeed, we have a few stressed VMs on there as well. So what I can do is drill into that and get some more information about it. Okay, so this is, again, an area of the system where you can ask a lot of questions and get answers to those questions. Now, here, there's a bunch of different things you can select, but in this case, I want to do stress. Okay. Now, stress is telling me the undersized virtual machines. Virtual machines which are simply too small for what they should be. They have some workload. You've configured it with 1 vCPU and 4 gigs of RAM, say, but the workload needs more than that to actually run at its full performance. So this is what stress is telling you. These undersized virtual machines are VMs that are just simply too small to run at peak performance. And that's exactly what we saw. So we, in fact, see our VM in there, 2011 Q4BI. Now, the interesting thing here is that we can get some good data. So first of all, we have 1 vCPU configured, okay? And this is hard to see, so that's why I'm reading it. 0% CPU undersized. It means the CPU is actually perfectly sized. We're not too small there. We're not hitting any headroom issues with CPU. Memory, on the other hand, is 2 gigabytes. And it seems like 2 gigabytes is too small because 74% of the time, memory is too small. That means that 74% of the time, this VM is at capacity in terms of memory. So out of the last month, 74% of that month, or 6 weeks, 74% of that 6 weeks. Actually, in this case, I can see here it's a weekly interval of 4, so that's a month, 4 weeks a month. So it's been a month, 74% of that time has it been at its headroom there. So that's why we see this, such an insane workload value, and why the system has learned on the performance side, hey, this is a regularly occurring issue, so I'm not going to alert you about it. And secondly, the capacity side said, whoa, okay, you're getting a tremendous amount of stress. I'm going to jack up that risk value to show you that you have these long-term potential problems. So the remediation here is to actually make this VM larger, right? Give it 4 gigabytes or so instead of 2. So again, let's walk back through that. We look at something someone calls with a problem. It turns out they really have no idea what they've been talking about since the problem has been happening for quite a while now, like a month. This is not a new issue. vCops quickly told us that. I said, this is not new, this is not transient, this is not a one-off. This is expected, right? This has been happening for 4 weeks. What do you expect? And then it told us that through stress, hey, you got this issue, and here are the specific problems 74% of the time. So there's no manual work. You can just click around, ask those questions, and get the answers. So that's the second scenario. Any questions with that one? Yeah, a couple of questions. Yeah, I should have just come up with that one. It's a way to determine how much RAM to give it. So vCops will tell you that. If the VM is too large, it can tell you how much to make it smaller. Unfortunately, it is very, very difficult to tell you how much a VM would use if it had more, right? It's really hard to model that. It's a lot of the application, what the application is doing, what the expected workload is. So it's very hard for us to accurately model. Now, we can make some guesses and educated guesses, but we don't quite feel confident enough about them yet to actually put them here. The thing to do is to give it more memory. You can make an assertion based on this percent. So this one's really undersized, right? 74%. So this one you might want to give 3x, 4x even, start there. And then you can run the oversize report to say, okay, is this thing too large now? Can I bring it back down? So that way, you go up, and then you can come back down just a little bit to right size it, right where you want to be at. Another question? Yeah. Yeah. That's a good question. And I actually don't know. Yeah, no. So these all have question marks. I'm not sure why. There might be some sort of a data feed problem with the demo. I don't know. Do you? All your customers? Okay, right. It's not a feature. A peanut gallery up front. No, so it's possible that a couple of cases, I'm not 100% sure. It's possible that, so we have one VM, for instance, without data either. There may be some issue with this VM and collecting data for it. But you notice that, yes, all the data stores do not have it. I believe that may be because of the fact that, do we not compute stress for data stores? We should, yeah. I don't know. So I don't have a good explanation, yeah.
We have Chris Abel from Denver, CHI. We have this happen typically when the service account or the underlying account maybe that you're logged in with
doesn't have access. Oh, that's an interesting one. Huh. That's funny. We didn't see this one last time. I'm not sure. Something happened between yesterday and today to mess this environment up. So yeah, that's a fluke. Okay, well, this is the problem of doing live demos, I suppose. But yeah, so there should be data there, and I'm pretty sure. Anyway, let's take it offline. We can investigate some more. Any other questions? You have another question? Right. So the question was, okay, let's say I have a system that's normally doing 100 IOPS or 200 IOPS or whatever, and then for a few months it's like that, and then next thing you know it's doing 300 IOPS. Now obviously in terms of the raw capacity of the system, it's fine. So the question is, would we flag it, or what would vCops do in that case? Is that essentially the question? No. So let's be clear. Let's be clear about it. We would not show stress in that case. Stress looks over long-term behavior. What? Workload? Oh, right. So workload would not be showing red for that either. Workload's an absolute measurement. Workload's like stress. It's absolute. It says what's your demand divided by your capacity. That's a percent. That's essentially the workload percent that you see. You saw that 9,000%, which means it's trying to demand a lot more than it has. So the one that would change would be anomalies. So actually, let me just pop back over here just to give you a visual on this while we're talking about it. So you can see how anomalies is low. So in your example where, disk I/O goes from like 1% to 3% or something, this would all still be green, workload would be bright green. Depending on the system, though, anomalies might change. Now, if all it was just one metric went out of bounds, anomalies wouldn't be affected. But if that 200 to 300 change impacted a whole bunch of other things on that VM, then anomalies would turn red. Now, health may still be green because health would say, well, your workload is still low, but your anomalies is high, but maybe that's okay, right? So anomalies is a really interesting one where even small, subtle changes can actually sometimes have a great impact. And so anomalies is an interesting one to look at because it's not always indicative of a pure problem, but of something you're interested in, right? Something you may want to check out. Why did the behavior change? Was there a good reason? Did a configuration setting change? Could that precipitate eventually a performance problem? That's the sort of thing anomalies is looking at. Now, when anomalies and workload are both going abnormal simultaneously, that's when health's really going to go bright red because it's going to say, wow, now you're having a workload spike and that's not normal. So that's a real problem, right? So that's sort of the idea of how they work together. All right, one more question, I think, and then we should move on. Did you have a question still, or?
How does undersized VMs work if you have a 1 meg
how does undersized VMs report if you have a 1 megabyte limit on your 2 gigabyte VM? Right. So this is, so we compute something called limited demand. So again, it gets more, we had this thing workload and stress, and they're nice, and then I said it's demand over capacity. In fact, there's so many subtleties to exactly how we compute it, but we do compute what we call limited demand. So we assume that if you have a limit, in terms of stress, the limit is what you want. So we're gonna look at the demand capped at the limit, and then compare that to stress. So in this case, you set a 1 megabyte limit. We would say, oh, well, the VM looks fine because it's only using 1 megabyte out of 2 gigabytes. There's no stress. Now, there would be waste, possibly, because of the fact that you're not using any of that 2 gigabytes. So, yeah. Okay, so let's go back here real quick. Okay, so the third one we wanted to talk about was around problems in a VM due to change, configuration changes, and so forth. This is one of the most common causes of performance problems, actually, is someone goes and makes a change somewhere, and all of a sudden now you have a problem. Okay, so this one, let's pull up another one here. So the one they called in about was IIS web server. So this is a web server one. Okay. So let's go back here. Whoops, I'm sorry. I wanted to go to environment. Getting ahead of myself. So let's select workload, because we saw workload was high there. Okay. So again now, scroll up a bit. So we see this one here. We highlight over it. This is our web server. We see that workload's high, so 100%. We actually, it's hard to see in the back, but it does actually tell you that CPU workload is what's causing this high workload. And so we know it's a CPU issue. We see the host is mostly okay, and the clusters and everything okay. So maybe something with this VM is going on. So let's drill into it a bit. So again, very quickly, 100%. We see that the CPU is really spiked here. Memory, not too bad. Disk and network, not too bad. All the same things over here. Verify all that we just saw. Now let me show you a couple of other things we can do here. So we can scroll down, and we can see that we have a number of other VMs running on the same host as this one. So the thing I like about this is that what you can see is how widespread this problem is. Is it just this one VM has a problem with CPU, or is it many other VMs on the host? For instance, the host just may not have enough CPU capacity to go around. So we see most other VMs are green, so we probably think the host is okay. Just for demo purposes, we have the host right here. We can drill into it and see what's going on with it. So we get all the host stats. We see everything's looking green, green, green. We do see one red one, which I'll come back to in a second, but all the rest of it's green. Now, what the red one is we're actually showing the breakdown of what the VMs are using here. So this VM appears to have some sort of problem. It doesn't appear to be thrashing on the host at all, since there's plenty of unused capacity here. So something with the VM itself. So let's go back to our VM. So again, back to the IIS web server VM. Now this is a particularly powerful view here, and it's called the Events tab. So what is the Events tab showing? Well, what it's showing is performance data over some past period of time. As you'll see in a second, we can set it to whatever we want. And it overlays events and changes on top of that. So we can show the events that occurred on this particular VM. We can see the events that occurred on the parent object, the host. We can see the events that occurred on peer objects, other VMs that might be related to this one. Now you can see that this VM's actually had a problem for a while, right? This is looking at 7 days here. So let's drop it back even a bit further. So we can go, a year back. We can have specific date ranges, a week, 2 months ago, whatever you want. So for this example here, we'll go back 30 days, and we'll do that. See if the demo gods smile on us here. Essentially what it's doing is it's collecting the many thousands of data points that we have, as well as getting all the different events that we have. And so we have too many events to display in a meaningful manner. So we just display the first 50 or so. Now, you will know something very interesting. It went from green to bright red at one particular point almost a month ago. So let's drill into that. So I can get my zoom tool here. I can go and zoom in. So let's just zoom in right around this area and see what it shows us. Get rid of that one. We still have too many events, too much stuff going on. So let's drill in even a bit more right around here. Okay. Okay, we're missing one event. That's okay. Okay, so let's take a look what's going on here. Okay, registry setting change, something about McAfee, something, some IP information where registry changes, and wins registry McAfee, VS Core. Okay, so a lot of registry setting changes. Something happened here. 117 registry changes. The tools info, something just happened there. Software inventory, Super Scanner 6 installed. So it looks like someone installed an application in here, and then they rebooted the VM. Now this is what really gets hard to see, unfortunately, and I'm sorry I can't zoom this in, but there's all these icons, and they're annotated. These are all events, obviously. They're annotated on top of the different performance, the performance graph there. Now, when I select them here, they actually turn, the one I'm selecting turns gray. So right now, as the line curves up on the left-hand side there's one E that now looks a little gray, if you can see that. When I select the other one, the software installation complete, we see this one right here turn gray. So these are the ones right where we start to see the spike occur. So it looks like things are running fine. We're doing the installation. We have a few spikes here and there. And then finally, there's a reboot initiated by the administrator. So some administrator went in, installed this McAfee product, and then reboot that host. And so you can see the performance spike going up as the reboot is taking up a bunch of CPU and so forth. And then it just stays high. So something happened. Maybe that virus scanner sort of went crazy and did a bunch of things. Now, what I don't have in this demo, but what we can do is bust out to a different view, a view of change, and actually have a one-click rollback of this installation. Unfortunately, I don't have that in this demo environment here, but the point being that what I've done is I've started off at what appeared to be a performance problem, something with high CPU. I saw it didn't appear to be an infrastructure issue because there were no other VMs on that host affected. All the other objects related to that VM looked okay. And then I could go into this Events tab and actually get in-guest information to tell me what's happening inside that VM. So again, a lot of this root causing is why did it happen, what's going on, and that's one thing we got here. So the solution is to go and fix that. We can unroll that, roll that back, and then that will remediate the problem. So that's the third vignette scenario. Any last questions on that one? How are we getting the in-guest visibility? So some of it can be done using the VMware tools. Certain things we do need more of a full guest presence, and so we do use agents in those cases. So it's a variety of different use cases that we have to get data out of the guest. Especially for things like, we can actually monitor Hyper-V deployments and so forth, and AWS deployments and all those sorts of things. And when you have things that aren't running on vSphere, then we need to use more agents in that case because we don't own the hypervisor underneath. So there's not much we can do. Other questions? Yeah. What do we have agents for? It's really well, that's a big question. So again, there's many different things that we cover, right? Different disciplines, so compliance, performance, configuration changes. In terms of the compliance and configuration stuff, all the different operating systems are covered, regardless of whether they're in a VM or not. We have coverage for a bunch of physical systems, and I don't know, obviously vSphere. I'm not sure the exact list beyond that, but it's pretty extensive. And the performance side is the same. We have a wide set of what we call adapters that allow you to plug in and get data from all sorts of different data sources.
I thought there wasn't access for non-physical systems except if you plug in another tool like OpenView or something like that.
So the question was, I thought there wasn't access for non-virtual? Yeah, non-virtual systems unless you plugged in something else. So we have adapters that can go straight to many physical things, like for instance NetApp storage. We have an adapter for them. We have an adapter for EMC. The approach that we took was that many of our customers already have another monitoring tool in place, like Wiley or Nagio, something they've already done all the legwork of bringing that data in. So you have this data. So basically use it as a data collection framework. So we can just stick a single adapter onto Wiley, pull everything that they have over. That's a scalable approach that we found to sort of get out of the gate. So we support Wiley, Nagios, OpenView, Tivoli, Patrol, it goes on and on, right? We are starting to look now to actually bypass those and go directly to the physical systems, but that obviously takes more time because you need to really work to get plugged into those. So yeah, so these are all options, and we do have a pretty wide set of data connectivity today. Okay, I think we can take maybe one more, and then there'll be time at the end for Q&A as well. I'm not sure who had their hand up first, so maybe this gentleman here. Yeah, so the question is, okay, what about events that come from vSphere, right, from vCenter, things like vMotions and HA failovers and so on and so forth? And the answer is yes. We have a pipe into vCenter. We get all those events. We put them up here. We can actually do a lot more than that as well. We didn't talk about that much, that much in the demo, but we do have this faults badge here, right down here. Now, there's no faults here, but what faults is essentially an event-based system. So if you have an HA failover, that would appear as a fault saying, hey, your VM's got an issue. If it comes back up, the fault will go away. If you lose redundancy on a NIC or lose connectivity on that NIC or connection, we'll have a fault for that as well. So we do take a lot of these events and actually roll them up into state machines that appear as faults. Oops, we're not even looking at the right thing. I'm sorry, I apologize. So down the lower left there is where the faults are. Okay, so I think at this point, I'll turn it back over to Praveen to wrap up, and then we'll have probably 10 minutes or so at the end for Q&A.
All right, thanks, Kit. It's a good demo. So we talked about a lot of screens here today. So just want to do a quick recap on what we saw. So start out with the high-level problem statement on how performance, capacity, and config need to come together. So we saw a lot of that. We looked at these different scenarios and how we can use the culmination of these three data points to tackle real-world issues. We talk about the power of the visualizations and how you really need to manage at scale. You no longer can do things at an individual metric level. So we saw a lot of visuals that allow you to sift through all that noise and get to the root cause quickly. So one of the visualizations Kit touched on and stuff that we really like is what we call unofficially as a Skittles View, is the ability to look at the impact across the data center. And what's really cool about this actually is that if you think about it, the colors become sort of a leading indicator of urgency or priority, right? I mean, if you saw in Kit's environment, there's a lot of VMs that are green, so you don't care about the stuff that is green and is behaving normally, right? You really are focusing on the sort of the Christmas lights, like I need to fix on this right now, right? So this is a great way to zoom on a particular object, understand the relationship, and this typically takes a couple of hours. Like, is it the VM? Is it the ESX host? Is it the data center? But just on one click, depending on where you are, you're able to see the entire sort of impact, right, of the particular domain of interest. So that's a really cool view. The second one was alerts. And one point about the alerts is that I talked about how we codify all this knowledge and put it into the product. And so you actually alert on badges. And badges translate to problems, right? So what kind of problem is it? Is it a workload problem? Is it an anomalies problem, right? Is it a stress issue? And so this way, you no longer are troubleshooting at a static threshold or a metric level. You know, what is the right threshold value for percentage ready? Is it 20%? What is it? Like, you know, what is the problem you're trying to solve, right? So focus on that and then being able to sort based on either the badge, the time, or the urgency of when it happened, right? So that's a really powerful view. Then we looked at the details page where we sort of organized all of this important information into sort of an easy to understand location. So that's a details page that organizes all the KPIs, the key performance indicators. You can see immediately because we run analytics, we take the guesswork out and actually point you to the problem domain you should be looking at rather than jumping from one thing to the other. Then we can also break down the other domains and say, okay, from a comparison standpoint, was it the CPU, was it the memory, was it the network, was it the disk, right? We also have something that we didn't cover, but just a quick point out there is that we show you what we call as key metrics. This is sort of the distilled down, sort of filtered set of metrics based on all the metrics you collect, and think of it like a stack rank. So we actually bubble up important metrics for each of the metric groups you're interested in on things you should do next. So on one end, you figure out what the problem is, and then you go to this view to see what are the specific metrics I need to worry about next. We touched on the planning section. Really easy way to just look at the environment, not maintain those Excel files and rush at the end of the quarter to get your budget numbers in. Just look at this view, gives you a nice understanding of, at a glance, sort of what are all the objects that have been deployed in my environment, whether it's a host or a cluster, how much capacity do I have remaining for each of these environments, like depending on the object I select. Am I going to run out of capacity next month, next quarter, when, right? At the same time, also asking the question, what is that resource that is going out of capacity the soonest? Is it the CPU, is it the disk, or the network, or the memory, right? We looked at the Heatmaps view, a really powerful visualization to just sort of zoom out, take a high-level perspective of the environment, and use it for even use cases like remediation, where I want to understand how do I move these chatty VMs to a different data store, for example, or a different location, like a cluster or a host. And the good thing about this heat map is that it's really configurable. You can pick any metric you want, and you can make that as the size indicator, and then you can take another metric as the color indicator. You can even take disparate metrics, take like CPU, and then match it up with the disk I/O and do some kind of comparative analysis. We also talked about how performance impacts change, and how to get around those calls where they say, well, I haven't changed anything, right? And then, well, you did. So how do you prove that? And then being able to go drill down into the specific set of registry changes in the configuration module, or the VCM product, or what we call VMware vCenter Configuration Manager. And not only just visualize the change, actually take action and prevent this stuff from happening. You can easily roll back the problematic change. You can even set exceptions. If you don't care about your test workloads, and this happens on your test environment a lot, just don't worry about it, add an exception, and then move on. So that's sort of a high-level flavor of what you can do with VCOps. We actually have all of this stuff running, in fact, a more broader integrated environment where you're pulling in data feeds, even from AWS and other sources at the booth. So I highly encourage you to check out the booth and go through some of those use cases. Another thing you can actually do is just download the product and trial it for 60 days. Just stick it in your environment. It runs as a vApp. All it needs is a vCenter IP address, username, password, and then it starts collecting data, and over a period of time, you start seeing results. Thanks for attending the session today, and have a good rest of the evening.